Assalamu alaikum viewers. The topic of today's video is heat capacity at constant volume. So first of all, what do you know about heat capacity? Heat capacity is actually the amount of heat that is required to raise the temperature of a body by 1 degree C or 1 Kelvin. So the formula for heat capacity is C is equal to change in heat divided by change in temperature. Again, as you know that Q is a path function, means it is dependent on path. So that's why its differential here is inexact differential. Whereas the temperature is a state function. So that's why its differential here is the exact differential. Okay, so now what we are talking about here is the heat capacity at constant volume. The heat capacity at constant volume means dV is equal to 0, means the change in volume will be equal to 0, means V2 minus V1 will be equal to 0. So now, from the first law of thermodynamics, you know that change in heat is equal to change in energy plus P delta V, and this P delta V is the amount of work done on the system. Again, delta Q is equal to delta E plus P0. In case of dV, I have just written 0 because we are taking volume to be constant, and P multiplied by 0 will give me 0. Again, the change in heat will be equal to change in energy. So I can use both of these interchangeably. So now in place of this delta Q, I can just write delta E because I have just derived that delta Q can be equal to delta E when the change in volume is equal to 0. So now plugging in this value here, that will give me Cv is equal to dE divided by dt and V. This V is representing that we are calculating the heat capacity at constant volume.